So the next module is reviewing and simulating models, an important part of MBSE. So first we'll talk about product quality and product design quality. So we all understand that the quality of products is very important to their success. And some nice examples: Apple iPhone, of course, perceived as a quality product. Unfortunately, another product, Samsung Galaxy Note 7, had some problems. It tended to catch fire. But of course, Samsung make very many fantastic high quality products. This was just one public or well-known failure. Japanese cars, very well known for their quality in many different areas, and one of those examples is the Honda VTEC engine with very, very low failure rates. It's been a very successful engineering design compared to maybe a car made quite near me in Northern Ireland, the DMC DeLorean. Now, I'm sure we all recognize this from Back to the Future as a pretty cool car, but unfortunately the quality of it was terrible. It was slow, heavy, it fell apart, lots of things didn't work. So although it looked great, the actual quality of the design was really poor, and the company did not survive long. The British government lost lots of money they invested in this company. So quality is really important. It improves product and brand perception. It builds customer loyalty, leading to increased sales. It can help you reduce costs through less redesign, fewer defects, and fewer product recalls. And we all know about some very expensive product recalls for cars, airbags, and other things that have cost some companies a huge amount of money. So with that in mind, what makes a product high quality? Well, it has to solve a problem. It has to provide the right features, the right functions. It must be reliable and deliver the expected performance. I think nowadays we all agree that it must give the user a great experience. Even if it's a dishwasher, cooker, a car, private jet, whatever the product is, there's a user somewhere, and they need a good experience, the best possible experience. And in the background, all of this has to conform to any standards or regulations. Though, as we know, it's not easy to build quality products. It's very easy to build products without good quality. So to optimize quality and deliver the best value to customers, product designs must be optimized. And this is where MBSE can really help companies. The real value of MBSE is helping us review, analyze, simulate, and then optimize the design of a product. So if we look at those areas, understanding the problem, providing the right features, delivering the right performance, great experience, and conform to standards. We have several features in Windchill Modeler that can help us do that. So requirements management. We have requirements diagrams, requirements items, and these help us to understand the problem. Capture and manage business technical requirements. Decompose those requirements. We see here decomposition. And then build relationships or identify relationships with other parts of the design. Obviously, the design needs to satisfy these requirements, so those traceability connections are very important. And this is where we can clearly state the standards and the regulations that we have to adhere or conform to. Use cases help us to understand the problem in more detail. They elaborate on requirements, so they provide more detail and context. Requirements are text. They may not explain the context. So here with the use case and the descriptions, we can explain more about the environment, the users, the other parts of the system that are being used as well. And this helps us to understand what are the right features and functions. From our requirements set, we can start to map use cases. Okay, we must be able to drive the vehicle. So we need to have some functions: start, accelerate, steer, brake. So they help us to understand the complete picture. And that helps us to agree and decide what functions the product solution needs. Provide the right features and functions. Activity modeling that we can see here shows a sequence, or really a process, of activities that the system will complete. So these are all connected to the systems model. But we can see that we have an action called push accelerator, which provides an output, and then an input goes to provide power action. So this then sends a message to drive power and the transport mode command. So we can start to understand how the process for the user and the process for the product will actually flow. What aspects of the design works together to satisfy those requirements, those use cases, in what kind of order. So we're starting to understand the behavior of the design of the solution. We have activities, events, inputs, outputs, and flows. Decisions, joins, and forks. State modeling is similar to activity modeling, but it's not focused on the actions and activities. It's focusing on the operational states of a system. So this helps us to understand how the system changes over time and how the functions are used over time. It helps us to be reliable and deliver the expected performance, because we can see here that we have different states. Off. If we start the vehicle, we move into operating state. If we turn it off, we go back to off. When we're in the operating state, we can be idle, accelerating, cruising, or braking. And then we start to understand, how do we move from one state to another? What's the transition? And of course, this needs to ultimately become a function that the user can then initiate. This gives us a model that we can actually execute. So we can turn this on and then inject events to trigger transitions. So Modeler allows you to animate this diagram so you can trigger those events and see the behavior, what state we move into, what actions or what functions are called to trigger these state changes. So it gives you a powerful insight into how the system will behave in different conditions with different events. Sequence modeling is again similar, but it's a little bit more low level. We're now actually starting to use elements of the design. So you may have seen something like this, but we can add in parts of the system. So there's going to be a block called a power control unit, electrical power control. Whatever entities we might have in the solution, we're starting to design those elements now. So this will describe and verify the behavior over time, specifically the interaction of objects or elements of the system. We can also include the human dimension here. So most of these are functions that a human would be able to initiate. And we see the event or the operation. A human would start the vehicle, and that would then send a command to this block. The block would then send another command to the electrical unit. And then this will send a message back saying it's ready. So we started really in requirements, which is what does the customer want, the user. Then we started to understand the context more with the use cases. And then we started to think about how do we realize those functions? What are the main states of operation? What are the main sequences? And what are the main design objects or system objects that will be involved? So step by step, we get a clearer picture of what the behavior of the system should be. And this ensures that we provide the right features and functions, and we can be reliable, and the system will deliver the expected performance. Because we understand very carefully how users and system elements interact. And of course, this gives us a basis for starting to write the software that will be underpinning a lot of these capabilities, as well as the hardware and the interfaces we need. In some cases, you may need to perform calculations. So to actually model a system, you might want to define and understand the engineering equations and calculations that will be part of your solution. So engineers typically work these out and then provide the answer in the result in the design. But here we want to model the workings out. We want to model the engineering principles and test them out. So we use, that's an error there, that should say parametric diagram, apologies. So this helps us again test out the expected performance. So we can define those calculations and equations that represent the system behavior. Typical example, of course, would be power output from an engine or an electrical motor and how that responds to the fuel input. So we define constraints, parameters to capture all of the values, and then we can define the actual equations. We can input any technical engineering parameters. So if we have any conditions that the system must conform to, fuel efficiency, as an example, carbon emissions, these can be inputted and then tested and simulated. We have some tools to help our users. One of them is Reviewer, and this is, again, helps us ensure we have the right features and functions. So it lets us review the system design. And there are different types of reviews. So the most common one is ensure requirements have been satisfied. So if we have a set of requirements for our product, to make sure that we've implemented all of the functions we need, we can run a review that will tell us some of these requirements don't have a satisfying relationship. So it's kind of been left over, and we can see that from the review and then go and look at that requirement and think, oh, we need to take care of this in the design. Maybe we'd like to ensure that all requirements are linked to use cases. And these are just two examples. There are many, many types of reviews you can conduct to make sure that the design is as correct and complete as possible. It may be that there's standards or regulations. And of course, this won't tell you how to innovate. What it will do, it will make sure that the model you've built is correct and it's complete, and that you've responded to any regulations and standards. So I'm going to demonstrate this quickly, I think. So I've got the HSUV model open, and in the review tab, we have Reviewer. So this is a separate tool with some guidance at the bottom there. And we have a set of reports. And then we have a scope. So we can choose just a package or do the whole model. And we can choose priorities. So we can specify if something's a high priority or low priority, and then only review those. If I choose Run Report, it does a review of the open model. So it's done a high-level report of HSUV, hybrid SUV, the date and the user. And it tells us the things that have failed, the things that have passed, what was ignored. Scroll down, it gives us the list of reviews that we've done. So here's a really obvious one to understand, not on diagram. So these are items that are in the model. So some of these items that are in the model, but they've not been actually added to a diagram like we see here. That might be okay, but in some cases you might want to have everything in your model shown on a diagram somewhere, but not really important. Missing data type. So that is a little bit more important. Attributes and parameters that don't have data types. So here's a list of the results. This is an attribute called transmission control. We can add a comment. It's okay. Checked. And then the review item is ignored. So we've kind of said it's okay, not a problem. Let's add a comment. Need to double check this. Next time we review, it'll show that comment. And then let's go and select in Modeler this particular item. So if I click this left front wheel port, it's chosen that, selected that port for me. And it doesn't have a data type specified. So I can see here that it doesn't have a type, and as it's a port, it should do. So I can then go and correct that model. And that one, yeah, okay. So I've given it an integer type. It probably might not be the best selection, but that's just an example of how you'd use Reviewer to report problems in the model definition. Have a look at the report, and then go and fix the model, fix the design. Okay, now if I go to configure reports, I can choose what we search for. So some of these reviews have been turned off. So we can go and add them back in if we want. There are some related to OSLC links. And we can create a custom report as well. So you can specify a user-defined report. And using the scripting language, you can specify exactly what gets checked. So this is what companies like BAE Systems do. They write custom reports that check exactly what they want to be checked at different stages in their project. We also have the ability to do quick review. So if I choose quick review, it says review is ready. So if I now choose a package, let's choose that one. I can choose the review type, let's do low level design, do quick review. And in this case, it reports the information directly into Modeler. So rather than having to go into the separate reviewer tool, you don't need to leave Modeler. You can call it directly from in here, and the report comes out in this window. And you can continue working on the model while it takes place. So this makes reviewing a lot easier as you're redesigning and adding new components to your model. Then you can very quickly just keep re-reviewing and then continue on with your work. So this is nice. We like the idea of being able to check your design as you're working on it. So it becomes a regular process and improve the quality of your models and the quality of your design. Okay, So that's what I just described, the quick review capability. It's a demo, just done a live demo. We have another module called SciSim, and this is where we can actually execute the model. So we can connect up aspects of the design, the executable aspects, and things like state diagrams, block diagrams that show the system architecture. And then we can mock up user interfaces as well. We can build user interfaces and then execute this as an actual system. We can inject events, so we can trigger state transitions, we can initiate operations, and we can see the impact or the results of the system in our mockup. So this might just be a test app, so we can test it, or it might be a mock-up of the user interface for the product. So the idea here is that we're validating the behavior of the model and ensuring those requirements are satisfied. It builds upon the sequence diagrams, the block structure architecture, the state diagrams, the operations and events that are defined. And when all of that's in place, we can actually simulate the system and make sure the design is the best it can be. We can verify user interaction and the interfaces in the system and also with the user. And it provides a way to demonstrate how the system will conform to relevant standards or regulations. We can capture these simulations and use them as proof that the design is correct and it will deliver the functions that we need. We integrate with another product, a third-party product that's now ANSYS, called Model Center. So this is a good product. And that's one of the reasons they bought it. So it provides a platform for simulation. They have connectors to lots of different tools that provide simulation capabilities. New web page. So they can connect to other things like ANSYS, like Simulink, like Excel. I think there's about hundreds of different tools that they have connectors for. And the idea is that we input a system architecture model, just as we've described, and then Model Center can run the simulation. It will actually do the execution of the simulation. It will bring in all of those parameters, all of the operations, all of the logic, all of the entities, the elements. And it will then run the simulation, and if needed, it will connect to separate tools. So here's some of the lists: MATLAB, Nastran, PTC Creo. They have a nice demo where they run some engineering analysis with an MBSE tool and then modify some CAD geometry in Creo. So that's pretty cool. It enables you to ask what-if questions and do trade-off analysis. So you can have different options in the design and look at different design alternatives very quickly. So it's a nice solution and we can connect to it. So design constraints, parameterized requirements are in Modeler. We provide those as inputs to Model Center, where it performs the maths, the calculations, sends the results back, And, typically we'll have a requirement that we're testing against, and it'll give us a pass or fail status. Let's try and have a little look at that graphic and a little closer. So in this example, we've brought in some blocks from Modeler. We have some constraints and equations defined, and then an execution plan in Model Center. It will then perform the maths and then give us an output result. Requirement is satisfied in this case. So for companies that really want advanced simulation and already have tools they use, this is a great way of connecting Modeler to those tools and doing that simulation run many, many times with different design alternatives. You can conduct thousands of simulations quite quickly and have all of the different possibilities evaluated, and then look at all of that information and try and pick the best alternative from the different design options. There's a demonstration of us doing this. I won't go through that now because it's quite long. We also have a direct integration with Simulink, so we can evaluate block structures, evaluate our architecture, and do co-simulation. This integration is quite limited capability. So really connecting through Model Center for Simulink is probably a better option. Okay, so that's how we review and simulate our system models. There's lots of options for our customers to ensure that they build the best possible products. And of course, stepping back, this is the goal: to build high quality products, provide the right features and functions, provide the right performance, a great experience, and conform to standards. If we can do this, if our customers can do this earlier in the design cycle, before we've done any physical testing, before we've done any prototyping, manufacturing, or detailed design, we save a lot of money. So being able to simulate the design and evaluate it early on is a huge part of the value of MBSE.